guys, welcome to my first Verilog and FPGA tutorial. This tutorial serves as an introduction to Quartus, Verilog, and FPGA. So, what is FPGA? It is in short a field programmable gate array. It actually contains an array of programmable logic blocks. You can consider the FPGA chip as a circuit playground, and it contains many logic gates, blocks, and wires. We don't actually have to worry about what exactly inside the FPGA, since that's the job of those IC or chip making companies. So for this tutorial, we concentrate more on how to program on the chips. The saying of program here actually should be FPGA configuration. So it's kind of different from what we have been experiencing with programming in C or Python or whatever other computer higher level computer languages. This is actually writing some file to configure the FPGA chip so that this FPGA chip can behave exactly what we designed to be. So we are going to use a hardware description language to configure the FPGA. So to program it. This is programming. So there are many kind of different hardware description languages, say HDL. So in this case, we are going to use Verilog in this series of tutorials because Verilog is kind of looks like C language, and it's much simpler than other HDL languages. So we'll stick on Verilog in this case. And the IDE, you can see here, we're using Quartus II. You can download the free version on Altera, and Altera is a company that has been acquired by Intel in 2015. So that's saying FPGA has a huge potential in the future, and also it has already been used on many stuff like in the chips in the cars or even AI. So for Quartus II, it is very easy to install on Windows and Linux. Here, this is I'm using Windows. So if you're downloading the Quartus correctly and open it up, you should be seeing something like this. Okay, and I don't think they have the Mac version available yet. Now, okay, let's get down to the business. Since we have opened the Quartus, now first thing we already do when we create some project, we hit the new project wizard. In this case, this is a software, and by the way, I need to mention that I'm using the De1Soc from Tutotial. So this is a development board I have. This is a De1Soc. You can buy it if you're a student by like $175 or something. This is actually a Taiwan company made this, and there's a chip inside which is a Cyclone file. Okay, now let's back to the project wizard. Here's the introduction. We don't have to worry about it. Let's hit next. Here's a directory and what the place you're going to be save your project. So in this case, we just choose something probably here. We're using Quartus 2018, and now we create a new folder. So you can use whatever folder name you like, but remember, Quartus is being naughty, so it cannot have the Chinese characters in the past, so it have to be in English. So in this case, I'm going to say YouTube 1, and what is the name of the project? I'm going to say YouTube 1. Next. And project type, we have empty project. We want to keep it simple, empty project. add files. In this one, we'll mention this later in the other tutorials, because this actually is more like adding more packages. If in Python, it's more like import something, right? So for this first tutorial, we just skip. So next, and here this is a very important part. It needs us to select the family, device, and board settings, because all those programming you're doing here is actually on the software level. However, we actually want to import the settings directly to the chip. So it's very important that everything needs to be consistent with the chip and the software configuration. If you're choosing different, say for example, I'm using Cyclone 5 here, and if you're choosing different family, or even the same family, however different device, the thing is going to be getting some nasty here. So let's see. This is a Cyclone 5 and 5CSEMA. Okay, so name filter 5CSEMA, and the other one is 5F3166. 5F3166. Okay, here you can see here's available devices now is down to only one. It has core voltage of 1.1 volts and ARMs 32,000 something, and total IOs of 457. So we're just choosing this device as we tell Quartus to say, hey, this is a device I'm using. Okay, and click next. For EDA tool setting, for this tutorial, we just hit next, so we don't care about it. Okay, now finish. Here, all those setups is telling Quartus what chip I'm using and what path you need to save all my files. Okay, this may take some little time. Okay, here it's done. Now we can see at the left board there's an entity instance. We have a Cyclone 5, 5CSEMA 5F3166, and the project name is YouTube1. Double click it says can find design in the YouTube1, because we actually just create the project but doesn't create any files or any design for it, so it's fine. And now we need to create some new files. You can click here on new or file, new, both are the same. And here's the several files categories. In this case, we're using block diagram or schematic file. In the later series, we're using Verilog HDL file. Of course, there's a VHDL file as well, because they're using different HDL language. For this one, I'm just showing how the course work and how you're designing a simple project here. So I'm choosing the block diagram or schematic file. Okay. Now we see here is a block 1. This is a block diagram file. The file description is very funny. It's called .bdf. It's block description file. And here there's several things on the top over here. This is very common in some EDA tools, or if you ever design a circuit on a computer. Now we're just trying to design. What should we design? Let's design a 3 input AND gate. Okay, 3 input AND gate, and using two input AND gates. So in this case, we need to use two AND gates, 2 to 1 AND gate. So here, this is a symbol. We can choose primitives here. There's a buffer, logic, other, and pings and storage, whatever. We can see here's a lot of logic blocks in here. So this is exactly what I'm saying before. Say FPGA is a circuit playground. So now we choose AND 2. So this is a 2 input, 1 output AND gate. Of course, you can choose directly from AND 3 to design a 3 input AND gate. But in this case, we're using 2 input because I like it. Okay, Now, after clicking yes, we will have a little symbol here. When we click the left button, here we actually put a 2-to-1 AND gate here, 2 input and 1 output AND gate here. And we can multi-click, we create severals, and we use delete 1. And when we click the arrow key, we can just drag the symbol around. Now here the thing is, when we create the AND gate, they are actually just functions in Python. Like if you're comparing Python, they're just functions. They don't have parameters. They don't have the parameter passing. They don't have returns because they just is a function. Then how do we say connect these two things? We can use this one. We can use the, what is it called? This is called orthogonal node tool, whatever. This is a little line thing here. We just click it and then connect it. That's it. And when we just drag this around, we see the line is still there. The wire is connected between these two components. And after we connect these two actually behaves like this circuit here actually behaves as a 3-input AND gate. However, here we don't have any input and output. You might say, oh, these two are input, or this one is the output. However, we don't have the pins because since this is an FPGA is a chip, we have to assign pins so that the output can output to a wire or even to a LED or even whatever. So here there's a 3 type of inputs. For here we only need input and output. So when we click input here, we just put it over here and over here. And then we click output, we place it over here. Okay, now we have to drag it to make sure they are connected. Okay, cool. They are. Oh, this one doesn't. Let me use the orthogonal node tool to drag and connect it. Boom. Done. Oh, okay. Now we have a pretty cool circuit. And what should we do? Let me just delete. Okay. Let me do this again. Boom. Okay. Now we have a pretty little 3-input. Actually, this is not 3-input. Now we have a 3-input circuit, 3-input AND gate circuit, and now what should we do? We can see here there's a pin name 1, 2, and 3, and 4. However, these pin names are just the pin names assigned by the software. And however, this thing, the circuit board, doesn't know what does that mean. So to them, we have to assign the pins. So we can usually assign pins by here using pin planner. And after loading the pin planner, we can assign the pin names one by one. We can say create a new node name and assign locations for it. However, this is very complex and very time consuming. So usually we may have something like this, something like a De1Soc.qsf, this file. This file actually is provided by the Intel, by the Altera already. What is this QS file? A QSF file. It is in short of Quartus II setting file. So actually, it's a Quartus II setting file. So we can see here there's a set global assignment name family cyclone 5, set name devices 5CS blah blah blah, and top level entity is De1Soc blah blah blah, and you can see further down over here there's a ping dash 1AE26 to hex 00, and hex, this is for hex. Let me find switch. Okay, here's a set location assignment ping AB12 to switch 0. This actually set the ping 8, this ping to a variable named SW0. Okay, to a variable named SW0. You can consider this as a macros in C. Okay, this is a macro definition in C. So we can directly import this. However, we don't have to worry about the ping assign one by one. We just import the QSF design by just import this file. So we just import this D1SOC.QSF. This is exactly the same file I opened over there. And hit OK. It will import all those ping assignments in there. So when we're trying to say, for example, when we're trying to link the ping name 1, link the ping, let me just make it kind of big over here. When we ever trying to link the ping name 1 to switch 0, we can just name it switch 0. And also ping name 2 is switch 1. We can directly name it as switch 1. So here I will do SW, rename it to SW0, and this one will be SW1, and this one will be SW2, and since this is the output, we will output to LEDR0. Here we have input as 3 switches over here, and the output as a LEDR, which is a LED light on the index of 0. Okay. After we import the assignments and complete all this, we just hit save. In this case, we'll just save here as YouTube 1. Remember, you have to, when you design when you create a new file and also save the new file, you have to make sure the file name is the same as your project name. So it means that top entity name should be the same. Okay. After that, we need to compile. Okay. This step is just start compilation. This is what the favorite thing we need to just hit run. Okay. So on processing and start compilation, we just sit there and wait. Since my computer is kind of slow and I don't have, this is just my desktop, this is just my laptop, so I'll skip this by just copying. Hey, the compilation has finished. Here's a huge report. So the flow summary says, okay, this one is it's successful. Okay, it's successful, and the tasks they're performing is quite a lot for just building a 2 AND gates. Okay, for just building 2 AND gates. And let's see. Here there's a lot of report. Just scrolling down. Here's some warnings, but don't worry. Some warnings it just doesn't make sense, because here's ignored 5071 assignment for entity De1Soc. Entity does not exist in design, which is fine, because in this design we only use what 4 things, and this entity D1SoC, actually this warning is, I think it's because mine import the pin assignment QSS file is not exactly same as D1 dash SoC. It's D1 SoC whatever. And here there's a no clock defining design, which is fine. I don't have any clock. This is just the combination of blocks. And eventually combination was successful, 0 errors. There's a huge amount of warnings. We don't care about it. There's 0 errors, fine. Now there's an easy way to tell you whether the design is correct. You can go to tools and then go to Nalus viewers, and here is the RTL viewer, which I think it's a registered transistor level viewer, I guess. When you click the RTL viewer, it will pop up a window, and then wait a second, and it should be pop up a circuit that the quarters sync you have designed. So I have designed a 3-input AND gate, and eventually the quarter seems to understand what I'm designing, and it's it's simplified my design. Actually, it's directly using a 3 input and 1 output AND gate. So in this case, I think my design is fine. My compile is works, and then we're trying to write the design to the FPGA board, to the D1SoC. So in this case, we're still using tools, and we should use programmer. Here, programmer, and in this case, you need to ensure that your FPGA board has connected to the electrical charge, and also this is a JTAG. This is a JTAG line where the N1 is USB, so it connects through the USB from the computer and using a USB to JTAG to the D1SoC. This program is the default program that the Tarasic D1SoC originally has. So every time you boot up the device, and you will see this this program. So it actually means your device is good, is is a good device. It's not some some false one. Now here we see here it pops up the programmer window here, and we should see here hardware setup mode JTAG is correct. However, hardware setup, it says no hardware. Okay, this is a no hardware. Although you may see here this is a 5CS EMA 5F31. This appears here because we tell quarters. Here, this is the chip. However, the quarters itself doesn't detect the FPGA board here. So we need to go to the hardware setup, and so here is the D1SoC. We just add hardware. Okay, oh, this is whatever local. Just add it. Okay, D1SoC current selected hardware D1SoC USB 1 close. Now this is a hardware setup, and we use auto-detect. Auto-detect. Here are several JTAG ID for device for this device, which use 5CSE MA5. Okay, and this is doesn't match a programmer's device list. Yes, update. And now we see here there's a 5CS EMA5, and also there's additional ones because we're not directly programming with the Cyclone 5 chip. We're programming with a development board. There's kind of several APIs around it, so we don't have to worry about it. So for here, we just click the 5CS EMA5 file, and there's a file column. There's a none. We double click it to change it. Okay, to change it. Usually it should be in output files, and here's the YouTube1.sof file. This is actually the compiled project. So this is what we need, and we just click open, and we're trying to write the output file to the FPGA chip, and then we choose program configure, yes, and verify, no, blank check, no, examine, no. So we just choose program and configure. It's fine. Then we just click start. When click start, you see here there's a progress bar. It says 100% successful, and you will see here there is no original program anymore. The lights are now flashing. Here, this is the simple project I wrote, so there's only these three switches will work. So switches 0, 1, 2. And since it's a 3 input AND gate, so when we push them up at once, you'll see here there's a LED R0. This one lights. So this is the 1, and when 3 inputs are high, the output is high. Okay, this works. And when any of them is not high, is 0, the result, the LDR doesn't shine anymore. It just, the result is 0. Okay, so when everybody's high, the output is high. Okay, now this is our first Verilog FPGA tutorial. What we have done is open Quartus and create a new project, and also using block diagram file to create a logic gate, and then write the logic gate. Compile the logic gate, and then write the compile stuff to the FPGA board, and then run the program directly on the FPGA board. So this concludes my first FPGA tutorial, and we'll see you next time.